In this lecture, we'll talk about geometric sequences. Okay. Previously, we talked about arithmetic sequences. That's one term minus the previous term is a constant. Now, for the geometric sequence, if one term divided by its previous term is a constant, then the sequence is a geometric sequence. Here is the example: 27, 9, 3, 1. Is this a geometric sequence? Okay, we want to identify if the following sequences, 1, 2, 3, are geometric sequences. Now, 9 divided by 27, 9 divided by 27, one term divided by its previous term, that's 1/3. You can see both numerator and denominator divided by 9. We then have a 9 divided by 9 is 1. 27 divided by 9 is 3. So it's 1/3. The ratio is 1/3. 3 divided by 9, you see both numerator and denominator divided by 3. Then we have a 3 divided by 3 is 1. 9 divided by 3 is 3. Okay. And 1 divided by its previous term is 1/3. So then this sequence is a geometric sequence. Okay. So as I wrote here, the sequence is a geometric sequence. Now if we look at B, 25 divided by 5, that's 5. 125 divided by 25, its previous term, is 5. Okay, you can see that. So, see, 125 divided by 25 is 5. Okay, and 625, fourth term divided by the third term. 625 divided by 125, this again is a 5. So this one, B, is also the sequence is also a geometric sequence. Okay. All right. Now, the last one, C. 15 divided by 6. 15 is negative. 6 is positive. You can do that. It is negative. This is negative side. Okay. 15 divided by 6, negative 2.5, which is negative 5/2. Okay. You can do this by using the change in this 2.5 by using to the fraction by using the calculator. You can do, as I remember, is math. After you click on math, you will do PRB, I think. Not PRB. Math, just the first one, you see, FRAC. Okay, if you hit on 1, and hit enter, it gives you negative 5/2. Okay, that's the one down here. Now, the third one divided by the second one. At 37.5 divided by negative 15. So you then have a negative 2.5. And then 93.75 divided by 37.5 is 2.5. And here is negative divided by positive, so we still have a negative. Okay, so all those three sequences are the geometric sequences. Okay. Yeah, previously for arithmetic sequence, that's 110 minus the previous 10 is a constant. That's different. Right now here is 110 divided by its previous 10 is a constant. Okay, now let's look at the formula. Formula for nth term. Okay, let's assume this is a geometric sequence. Okay, you may write geometric sequence here. This may be better. Given geometric sequence. Okay, like this. Then you know 110 divided by its previous 10, A2 divided by A1 is a R. And A3 divided by A2 is also R. Those two R's are the same because that's by definition. Geometric sequence 110 divided by its previous 10 is a constant. So A4 divided by A3 is the same R. All those R's are the same. And AN divided by the previous 10, that's AN minus 1, is R. Okay? So, all those R's are the same, so it's a constant. Then how does the formula look like? Look, down here, if we have that both sides, I want probably to shade this one. Yeah. If both sides multiplied by A1, so this A1 cancel this A1, we have A2 equals A1R. Okay. Similarly, for the second one, we know A3 divided by A2 is a constant R. Okay, and both sides multiplied by A2, you cancel A2, so you have A3 equals A2 times R. And down here was A2 equals A1 times R. From here you can see a pattern is what? A2 equals A1 times R. A3 equals A2 times R. Okay, A3 equals A2 times R. So if you use R to hit on A1, you get A2. If you use another R to hit on A2, you get A3. Okay, that's the pattern. Let's see. A4 over A3 is R. Both sides multiplied by A3. You cancel A3 here, A3 with A3. And then you have A4 equals A3 times R. Okay, so it's the same thing is that you use R to hit on A3, you will get A4. like we did, we use R to hit on A2, we get A3. Okay, so similarly, here is the same, the last 10. An over an minus 1 is a constant, both sides multiplied by an minus 1. And you cancel an minus 1, you have an equals an minus 1 times r. Okay. So in this case, is again you use r to hit on the previous one. Then you have an. Okay. Okay. So this is like recursively defined. A2 depends on A1, A3 depends on A2, A4 depends on A3, and An depends on An minus 1. Okay. Now, we need the general formula for nth term. How are we going to do it? You know, here is A2, here is A2, the one I marked. And here is A2 too, together those two, because A2 equals that. So, if you replace A2 by A1R, then A1R is A2, there is another R. So that's R times A1 is A3. So that's the one down here. Okay? Yeah. Again, A2 is A1 times R. But there is another R down here. So R times R is R squared and A1. Okay, so A3 is actually equals A1 times R squared. Okay? All right. Now A4 depends on A3, but A3 is A1 times R squared. Okay, A3 here is A1 times R squared, but there is R down here, so R times R squared is R cubed. Okay. R cubed, and you have A1 here. Make sure A1 here, but here is A3. Okay, and you can see a pattern down here is what? The subindex 1 plus 3 is 4. Subindex 1 here plus the power exponent is 3. And the subindex 1 plus the exponent 1 is A2. Okay? Yeah. Similarly, you can see the last one, that would be the subindex, okay, plus the exponent n minus 1, you'll get n. Okay, so that's the same. So this would be the formula we wanted. Okay. Yeah, comparing this one with the arithmetic, that's different. Okay. Okay, now this is the formula we want to remember. A sub n equals A1 times R to the n minus 1. Okay, and that's the formula. We are going to apply this one.